two main jet configurations that you'll see in the eFoil space right now. So on this side, we have a large diameter jet, and on this side, we have a small diameter jet. So the large diameter jet is characterized by an impeller design that is 90 to 120 millimeters or so. And the small jet is in that 40 to 75 millimeter range. So quite a bit difference in diameter there. And then again, the aspect ratio. The large jet's shorter. The small jets typically have a longer cone. So you'll find the large jet on lift foils, the Flite Jet 2 that they just released with the Series 5. I think Sifly is from what I've seen, and Waydoo. And the Flite Jet 1 was a small jet and also an Audi airfoils, and it appears that the Awake design is a small jet diameter as well. So you can see here just kind of the aspect ratio and kind of a pictogram of each design. So if we flip over into a little bit of a pros and cons list, we'll talk about some of the advantages and disadvantages of each design. So if we start on the large design, there's more manufacturers which have gone this direction. And I believe it's primarily because it is a more efficient design. So the larger diameter you can make the propeller, you're going to get more power per watt and generally longer battery runtime just from having a larger propeller blade. The next thing that I think is it makes the product for lift foils possible, and I believe other companies, it simplifies them as well, is that the larger diameter props can run on a lower RPM. So they'll use these larger direct drive motors, which originally were for the 3-blade open props or shrouded, and they can put this jet straight on there. So like a demo with the LCS Jet, you can switch between the 3-blade and the jet, no problem at all. One other advantage of the larger blade design is that you can have slightly larger clearances and looser fits with your propeller and shroud due to a lower pressure gradient. And that's important for manufacturing when you're making these out of plastic and making thousands and thousands of them. Just opening up your tolerance and design window is a major help on the engineering side. So that's another good reason to go with the larger size. And then finally, I think the manufacturers lean towards it because they offer more torque. So you might have novice riders or heavier riders that they need a little bit more oomph when they're in displacement mode and planing. So the larger blade diameter will just give you a bit of extra kick on the low end. The main disadvantage is that it has more drag. It's a larger diameter. It's not going to reach the same top speeds. And it does have that stabilizing effect of a shroud. Some might say that's a positive, some might say it's a negative, but that is a key design characteristic to be mindful of with the larger diameter jets. So if we switch over to the small jet, we look at the pros and cons. It does have a higher top speed. That propeller is spinning faster, and the water exhaust, let's say, is coming out at a higher speed, which will allow a higher top speed. It has less drag. It is a smaller diameter, and you're going to have less drag, and that again contributes to the higher top speed. So that's sort of where the positives end. Now let's get to the negatives. It is a lot less efficient. You have to spin the propeller significantly faster, and that has a lot of downstream effects. So when you have a high pressure gradient, and in this case, it's in correlation with this exhaust or the nozzle velocity, you have a lot more losses, viscous losses, pumping losses, those kinds of things. So in addition to being less efficient, the small jets are more difficult to design because they require, again, tighter clearances. And also the impeller is a much more critical part where you can't necessarily just sort of take the propeller design, the open prop, and tweak it. You need to go to almost a clean sheet, and it's on such a different part of the spectrum that you can have some significant difficulties with cavitation and other engineering challenges that make it hard to create an efficient impeller. On top of that, again, we mentioned the tighter clearances. Because you're using a higher pressure difference between the exhaust and the intake, you need to have a tighter clearance around the impeller. And again, that's not very conducive for a swappable, changeable system. So you see most of the jets that have this were either purpose assembled or you can't switch them at all. At least in the case of the Flite, it was still attached to the gearbox, so you couldn't take the jet apart anyway. Where with a lift, and I think with the Waydoo that I've seen, you have to assemble these yourself. So it's a different thing when you compare the two clearance requirements. It was a plus on the big one. It's probably a minus on the small one. They lack low end power. They just don't have a lot of punch. You really got to wind them out, and even then, it feels like using a garden hose to get propulsed. So it just has a soft, smushy feel. I'd say that's a negative for most eFoil users, especially ones who are just learning. So overall, it's a comparison between the design sizes. Now we can argue about what's a jet and what's a ducted fan. I'll just say that they both create pressure differences and they both exhaust fluid, and that's their method of propulsion. We're talking about squares and rectangles here. It's a fun thing to argue about, but at the end of the day, they're both jets. They have characteristics of ducted propellers and jets, so it doesn't matter. Just go ride the damn things and have fun. Anyway, I hope that helped kind of clear up what's going on in the eFoil space and how it affects their performance.